Now these are not, we're not talking about, you know, SSLs or Neves or, you know, the big production studios. These are broadcast type consoles. But you can see that's pretty pricey for a broadcast that in the TDM world. And that's where you have some big savings. And then, of course, the connectors, pretty much a wash. So bottom line is cheaper than analog, way cheaper than TDM, which was the sort of predecessor, the most recent predecessor. So a big cost savings in terms of the hardware. And that's if you want to go all the way. Consoles, routing, and of course all the interconnections. What about labor? A little harder to read, sorry. But again, zero for the punch blocks, a lot of wiring labor taken out of the picture. So a lot of hours gone away there. Same goes for some of the studio installations and setting up the punch blocks for and cross pairs to the console in each studio, distribution. And then maybe a little longer for programming than the old days, but probably no worse than a TDM router setup was. So big savings in terms of total labor hours there. And I mean, you know, look at the numbers. It was worse there for the analog days because you had so many punch blocks and pairs to worry about. At least you had some level of integration on the TDM world, but more expensive hardware. So, but you know, you win-win in both cases, and this is why this stuff is so attractive and being implemented so broadly right now around the world. Because of those numbers. We'd love it to be because it was cool technology, but basically it comes down to dollars. But whatever, when you get both good technology and flexibility and future-proofing scalability, and it's cheaper, I mean, you know, what's not to like there? So that's why it's pretty popular, at least in this very, you know, sort of rarefied space of radio broadcasting. But I expect that it's going to be even more broadly throughout audio. It's already in television and video as well, although the savings aren't quite so great there because you need much higher bandwidth for multiple video. But you don't have as many video signals in a typical house as you would audio signals. And we're talking about every audio signal being available at every input of every room being available to any destination in any place in the facility. That's pretty powerful. Maybe you don't even need that, but you get it, basically, without really even asking for it. So, and that scalability going forward is just really attractive as well for being able to not have to throw this all out and start over next time you need something new. You want to go to surround from stereo? No problem. You know, just maybe you need a bigger switch. That's about all. But everything else stays the same. More or less, and maybe a little different interfaces and so forth, but it's much more scalable. So that's pretty much it in terms of a quick run through what audio over IP is like in both the broadcast world and a little broader into the audio environment, even live sound reinforcement as well as post facilities and so forth. We have time for some Q&A here.
On these nodes, what are the typical track counts or channel counts of audio, and how much are these nodes roughly cost? You know, the GPIO units.
Right. Kirk asked about what the nodes are actually like in terms of cost and capacity. I believe that the ones we're showing here in these have, I think it's 16. Steve would be able to answer this question off the top of his head, but I believe there's 16, 12 or 16 analog ins, 4 AES ins, more or less, and then, as I said, just the RJ45. And then I believe it's 8 GPIOs, I think. In fact, we can look it up in the book, but you could go on the Axia website right now and we could find it. In fact, I could do that here if we wanted to. But in any event, they'll show you all the specs, and that's really just a choice because the capacity isn't really limited by that. It's essentially unlimited. Some of you may have heard of this technology called CobraNet, which was one of the first to use the Ethernet physical layer as a serialized interconnection standard. But again, it was proprietary, and it does have a fix. I think it's 145 channels is the max you can put on any single CobraNet infrastructure. This has no limit. I mean, it literally is just keep throwing more, it's just like a computer network. You want to just keep putting more computers on. Maybe it slows down a little bit, and if it does, then you need a bigger switch. Or, in extreme case, you need to go to fiber instead of copper. But, the point is, it is scalable, and there is no fixed limit because it is using an inherently scalable architecture at its core. So those limits, in terms of those numbers, are just literally what they decide to put in the hardware. And next year they may make a box that's bigger, or you put 2, 3 together, you stack another one. If you need a new one, you just buy one more and just daisy chain them. So it's very scalable in that respect. And they pick the numbers that seem to make the most sense at the time, versus the number of analog inputs versus the number of AES digital versus the number of devices you need to control for those 3. And then maybe there's going to be one with a video node on it sometime soon, so that's all scalable as well. The other point is, you may not even need the node if a lot of your sources are PC based anyway, and then you just dump the sound card and just install the driver and just connect directly, so you go straight in from the device. Yep.
On these nodes, for a lot of audio purists, they're going to be worried about A to D conversion, DA.
Yeah.
And that can get pretty expensive with a lot of those on your system. Are we talking about, if you're wanting really high quality conversions, is that going to be pretty expensive?
Well, the question was, how about the cost of A to D conversion, especially if you want high quality in the audiophile or the post world? And that's certainly an issue, but you've got A to D somewhere. So you're either paying for it in the console, paying for it in some Apogee box outboard, or you're paying for it in this node. So, and in fact, you can still do that in the brand X of your choice A to D converter outboard and just go in AES into the node. So it's not like it adds a cost to it. You need to, what's new here is the IP-ization of the signal, but somewhere you still need to digitize it first anyhow. And of course, A to D conversion is a key thing. They, on the analog inputs, these guys, this one particular company, and I would say this is probably true about all of them, are concerned about that. Reasonable quality A to D converters are available nowadays. This is broadcast. It's not like super high-end, audiophile quality, I guess, but it's very good. It's not, the sort of late 80s quality A to D converters. So they have, the broadcasters are still reasonably concerned about that. So the built-in ones on the analog inputs are decent. But yeah, sure, you might want something better. So you're going to have to buy that somewhere. So. But it accommodates either way. You want to use theirs, it's in there. You want to go outboard, do it, or you want to just, if you're using your console, if you've got really high-end A to Ds in your digital, very expensive console, you could still use this as a interconnection service. Again, maybe just replacing your router.
Could there be something that's just basically going AES from your console right into?
Absolutely, sure. And you just use the nodes there and just use them as all AES. You could probably, depending on the vendor, you say, look, I don't even want the analog. I don't need any of that. Just give me a full AES. And they do make AES-only nodes for people that want that. And you actually save money on that because they don't have all the A to Ds in them, or D to As as well. Because they have D to As too. You can use these both ways. Each one of these nodes is spider. It can be used on either end.